this session we are going to see the effect of temperature. The effect of temperature on the rate or rate constant. Rate or rate constant. Whether they are affecting or not, definitely the rate or the rate constant, because the rate constant is related to rate. If rate constant is changed, as well as the rate is also changed. And why they are all changed? The rate is why it is changed. If you see the distribution of the energy among the molecules or atoms, a very few percentage will be having low energy. And very few molecules will be having high energy. And the average energy molecule will be high. This we call it as the Gaussian distribution. And all natural phenomena would be following this Gaussian distribution. And depending upon the nature of the reactions, the molecule should have a different amount of energy to undergo a reaction. You should possess a minimum energy. That energy we call it as the threshold energy. Therefore, those molecules having the minimum amount of energy can participate and can undergo the chemical reaction. And such molecules are found to be a very few fraction of the total molecule, and they are called active molecules. And other molecules are called as passive molecules. And how much amount of active molecules present in a molecule? It is depending upon the concentration of the active molecules. The rate of the reaction is either increase or decrease and so on. Therefore, how to make the molecules, the passive molecules to be activated, you have to supply energy to those molecules. How to supply the energy, how to transfer the energy, how to infuse energy. The simplest method is to increase the temperature, and the molecules should be, passive molecules should be acquiring the energy, and they would cross the threshold, they would acquire the threshold energy. Now the fraction of the molecules having the threshold energy is increased. Therefore, as temperature increases, the active molecules will increase. Therefore, the rate of the reaction is also increased. And it is found that for every 10-degree rise in temperature, the order or rate of the reaction is almost doubled in majority of the case and tripled in some of the cases. And for the rest of the molecules, it is lying between double and triple. And which temperature and that ratio, that is called as a temperature coefficient on the reaction rate, mu, is called the rate determined at higher temperature. At higher temperature. Rate determined at lower temperature. The difference should be 10 degrees. Normally, which temperature this temperature coefficient of the reaction is studied? At lower temperature, it is taken to be 25 degrees C, and a higher temperature, it is 35 degrees C. In terms of the Kelvin, 248 Kelvin, and a higher temperature, 308 Kelvin. And therefore, mu is, and the rate is now, is given by the rate at the temperature 2, that is higher temperature, would be equal to rate at the temperature, low temperature, into its temperature coefficient. The temperature coefficient is for every 10 degrees centigrade, there is a rise of 2 times energy. Therefore, mu may be 2 or mu may be 3 or it may be fraction. This is the equation. Using this equation, we can calculate, we can work out for nearly 4 types of problems. What are the 4 types of problems here we are working to work out? What are the variables present here? First, you will see this. The rate at a higher temperature is a variable, first variable. The rate at the highest lower temperature is a variable. The mu, depending upon the nature of the reaction, it is also variable. Delta T, the change in the temperature, is also variable. Therefore, 4 types of variables are there. Therefore, we can have 4 types of problems. What are the 4 types of? You may be asked to find out the rate at a higher temperature. This problem can be solved only when you are given the other variables. What are the other variables present? The rate at lower temperature, that is T1. The temperature coefficient of this reaction and the temperature difference, delta T, the higher temperature minus the lower temperature. These 3 should be given, then only you can directly substitute this data in this equation and find out the answer. Or rate T1 may be asked. If T1 is asked, you should be provided with the mu and or if the rate of the reaction at a higher temperature, rate of the reaction at the lower temperature is given, you may be asked to calculate what is the rate temperature coefficient of the reaction. Therefore, if you can easily analyze the question formula, 4 types. One more type of problem may be asked, that is 2 sets of questions would be given and data would be given. That is, for A type reaction, the rate at T2 is this one, the rate at T1 is this one. Mu for this is equal to, let us assume 2, and the delta difference is this one. Now we do put the what is the rate of T2 for a reaction P for the reaction P. If rate at T1 is this one, and mu may be given as 3, and what is delta? If there is some other relationship may be given, we are going to see this, how to solve this problem. First, we take down the problem. If the temperature coefficient of the reaction is 2, find the ratio of the rate of reaction. Find the ratio of the rate of reaction at 40 degrees centigrade and 25 degrees centigrade. At 45 and 25 degrees centigrade. What is the formula? We have rate at higher temperature 40 degrees centigrade is equal rate at 25 degrees centigrade into mu power delta T by K. What is the rate? Here what is asked? Find the ratio of, therefore you convert the formula is as follows: 40 degrees centigrade and rate at 25 degrees centigrade. If a confusion arises, just write 2 and just write indicating the lower number indicates lower temperature, higher number indicates higher temperature. Mu. What is delta T? The difference between higher and lower temperature. Here, after converting degree centigrade to the Kelvin, subtracting, or without conversion, you can get the same difference. Therefore, we will be having a direct relation, subtraction, 15 by 10. And mu is given as 2, and it is 2 power 1.5. What is the value? It can be written as 2 power 1 into 2 power m, or it is equal to 2 into root 2. This is the ratio. If you follow this correctly, And now work out this problem. Two different order reactions, A and B, have the initial rates in the ratio 1:2 respectively at 27 degrees centigrade. The ratio is changed to 3:4 at 57 degrees centigrade. 57 degrees centigrade. If the temperature coefficient of the reaction A is 3, what is the temperature coefficient of B? This is the ask. Two different reactions are given, and one reaction temperature coefficient is given, another is asked. Second, we are going to use the one and only formula, this one. But two times you have to use the formula. One for the reaction A, another for the reaction B. First, we write down the reaction and equation for the reaction A, rate of A at 57 degrees centigrade is equal to rate of A at lower temperature 27 degrees centigrade. And its temperature coefficient is given as mu equal to A. Therefore, you can place 3. Power delta T is 57 minus 27, 30 by K. This is the relationship for the A reaction. Now you can write down the relationship or the B reaction. Anybody tell me the relationship for the B reaction? Tell me the relationship for the B reaction. Tell me. Rate of B at 57 degrees centigrade is equal to rate of B at 27 degrees centigrade. What is the mu of B in K trigonometry? Therefore, mu power 30 by A. Now substitute the given values. Initial rate of A and B is 1:2. Therefore, at 27 degree, A 1 into 3 power 3 and B 2 into mu power 3. And the reaction rate at 57 degree, A is 3 and B is 4. Therefore, the only parameter that is unknown is the mu. You can find out the mu, what would be the value. And that can be given as 3 by 4, 1 divided by another. You will get 3 by 4 is equal to 1 by 2. 3 cube. 3 cube can be written as 27 by mu cube. Or mu cube is equal to 27 into 4 by 2 into 3. That is equal to, what would be the value? This and this 2, this and this 9, 18. Mu cube is 18. Mu is equal to 18 power 1 by 3. You have to take the cube root for 18. You should have the ready reckoner. 2 cube is equal to 8. 3 cube is equal to 27. The value is in between this one. How much? 18. எப்படி எழுதலாம் சொல்லுங்கள் பார்க்கலாம். 18 power this approximately. If you Find the difference between these 27, 8, 2.5 cube would be having how much? 27 into 8, the difference 90. The difference is once again 9.5 is equal to 17.5. Now we have to find out the cube root for 18. Therefore, your answer is mu is equal to 18 power 1 by 3 is equal to 2 power 6, 2.6. What is the correct answer for the cube root? And check it whether it is correct or wrong. Or you can see the answers given, but now I have not given any answer to you. You give the answer and all this. Now, if you understand this problem, you can work out the problem given in the CSR examination in the year 2011. Take down the question. The rate constant of a unimolecular reaction, the rate constant for a unimolecular reaction was 2.66 into 10 power minus 3 per second and 2.2 into 10 power minus 1 per second at T 120 degree Kelvin and 360 degree Kelvin respectively. The rate constant in bracket in per second unit at 240 degree Kelvin would be option A 2.4 into 10 power minus 2. B option 2.4 into 10 power minus 1. C option 4.8 into 10 power minus 2. And D option 8.0 into 10 power minus 3. Now, you are given the rate constants or rate, whatever may be, the rate constant, we are having the same formula. You are giving the rate constant at two different temperatures. When two different temperatures is given, you can find the mu. If you find the mu, apply for the required parameter. Now we will write down the equation. That is 2.66, higher rate, 2.2 into 10 power minus 1 is equal to the rate at low temperature, 2.66 into 10 power minus 3 into mu into delta T. Delta T is the difference is 240 by 10. Multiples of 10, therefore is equal to mu power 24 is equal to 2.2 into 10 power minus 10 divided by 2.66 into 10 power minus 3. Apply your calculator and find out what would be the ratio. The ratio would be very nearer to what? It is equal to, if you 2 by 2.4. Why we have put like this? We have decreased 0.2 and also here we are decreasing 0.2 or you can write 2.5 into 10 power 2 is equal to 1.25 into 10 power 2. It is equal to nearly 80. 1.25 to 10 power 2, it is nearly 80. But the value is certainly higher than the 80. Because instead of 2.46, we have written as a 2.5. The value should be higher than the 80. Or we can write it as 81 or 82, etc. 82, etc. Okay. Now you have find out mu power 24 is equal to this one. Therefore, mu is equal to 81 power 1 by 24. Now you have found out mu from these two equations. Apply the mu and find out what is the rate at 240. For which you are in need of rate at lower temperature and you have to find out rate at the higher temperature. Rate at 240 and another equation, rate at lower temperature, say 120, and mu is equal to 81 power 1 by 24 into delta T by K. What is delta T? 240 difference 120. Therefore, it is 120. And instead of delta T, you can write it as del 120 by K. Therefore, it is equal to, right at 120 degree Kelvin is 2.66 into 10 power minus 3 into 81. It is nothing but power 12 and 12 by 24 it is half 81 half. And square root of 81 is equal to 9. Therefore, 2.66 into 10 power minus 3 into 9, multiply it, 9, or you can make it as a 2.7 into 9, it is equal to 6, or to 2.43 into 10 power minus 2. This is the value. So asked in form of question, and now your answer is 2.4 into 10 power minus 2. This way you can easily work out for this. And now take down the another problem. This problem is not so far off, but maybe asked in the future. That is, take down these two first order reactions having the same reactant concentration. Proceed at 25 degrees centigrade. The temperature coefficient of the rate of first reaction is 2 and the other 3. Find the ratio of rates of 2 to 1 reactions at 75 degrees centigrade. The options for this problem is A 243 is to 32, B 1667 is to 27, 42 is to 219, and 181 is to 32. Here, two sets of reactions are given, but the equation is, this is the equation. What is the equation? This is the equation we are going to use. The temperature dependency of the rate or rate constant is equal to rate at higher temperature to rate at lower temperature equal to rate at lower temperature mu into delta T by 10. Here you have to apply this equation 2 times for reaction 1 and reaction 2. Now I will work out the problem and I will give you a similar problem for you to carry out as an exercise and work. So first we will apply it for the first reaction. The rate of the first reaction at 75 degrees centigrade is equal to the rate of the first reaction at 25 degrees centigrade into mu. Mu is given as, what is the mu? Mu for the first reaction is 2 into delta T. What is the temperature difference in lower temperature is given as 25 degree and higher temperature is given as 75 degree. The difference in temperature is 50, and in the 50, how many tens are there divided by 10? That is equal to how many are there? 5 Tens are there. Therefore, delta T by 10 is nothing but 2 power 5. The data given in the problem is now written in the equation form for the first reaction. Similarly, we are going to write the data in the form of the equation. Rate of the second reaction at 75 degrees centigrade is equal to rate of the second reaction at 25 degrees centigrade. Here the temperature coefficient is given as 3, and the temperature difference is also that between the two temperatures, that is 50 by 10 equals 3 by 5. What is asked? The ratio of rates of second reaction to first reaction. Therefore, you have to put the second reaction in the numerator and the first reaction in the denominator, and divide each by this. Second by first. The rate of first reaction at 75 degrees centigrade is equal to divided by the rate. The first reaction at 25 degrees centigrade by 2 power 5. And here they are asking this ratio. And what about this ratio? Here you should know this. What is given, whether the rates are same or they are in the ratio 2:3 or 3:3 is given. Read out the first line. The two first order reaction having the same reactant concentration proceed at 25 degrees centigrade at the same rate. Therefore, rate of the first reaction at 25 degrees centigrade, rate of the reaction of the second reaction, they are same. Therefore, they cancel each other. Now the ratio would be equal to 3 power 5 by 2 power 5. 3 power 5 is, you can easily find out 3 power 3 into 3 power 2, that is 27 into 9, that is equal to 243. 2 power 5 can be written as 2 power 3 into 2 power 2. 2 power 3 is nothing but 8. 2 power 4 is equal to 2 power 2 is equal to 4, therefore 32. The ratio is 243. For the second reaction, 243. For the first reaction, this is present in the A answer. This is the answer A. If you understand this problem, now I am going to give you a problem similar to this. You can work out in your home and take down the question. Two first order reactions. A and B are having their rates in the ratio 3:2 at 25 degrees centigrade. At 25 degrees centigrade. What would be the ratio of the rates between B and A? Note the point here. There it is given A and B, but here question asked is B and A at 65 degrees centigrade. Come on. If the temperature coefficient of rates of the reactions A and B is 2:3. A and B. Here also you should be very cautious for which it is true, for which reaction the temperature coefficient is 3. Therefore, and initially 3:2. Which rate is having 3 times and which rate is having 2 times. And what is asked? B and A is asked. Therefore, you should be very cautious in working out these problems. Don't be patient. And options given are A, 32:243. B option, 243 is to 32. C option. 27 is to 8. D option. 8 is to 27. Why they are giving the answer? One is the reverse of another. Because here the question asked is, find out the ratio of the weights between B and A. Some students may calculate the answer to A and B. Therefore, in order to avoid the disappointment of such a student, they will also give the correct answer in the reverse. Therefore, you should be very cautious. Now you can work out this in a similar manner. But here the different ratios, initial rates are 3:2. Therefore, for A, rate of the A at 25 degrees centigrade, you put it as 3, and for the rate of B at 25 degrees, C adds 2, and work out the correct answer. Use the C answer. Go and check your answer. The last type of problem in this section is take down the problem. Two same order reactions. Two same order reactions. C and D are having their rates in the ratio 1.5:3. 1.5:3. Or in order to avoid the fraction, you may keep it as 3:6. So multiply it by, or divide it by 1.5. It may be converted into 1:2 in order to avoid the ratio 1.5. At 25 degrees centigrade. At 25 degrees centigrade. At what temperature? At what temperature? The rates would be equal. At what temperatures the rate would be equal? If the temperature coefficients of the reactions are 2:3. 2:3. The options are 41.7 degrees centigrade, B 30.8 degrees centigrade, C 15.2 degrees centigrade, D 8.3 degrees centigrade. Here, what is asked? What is the at what temperature rates would be equal? Therefore, you have to calculate the delta T. From the delta T, you can calculate the temperature. What is the rate at which the two rates would be? What is the temperature at which the two rates would be equal? The delta T is asked, and you work out and find the answer is 8.3 degrees centigrade. And with this, we have finished the temperature dependency of the rate constant and rate of the reaction.